Guys, gals, and fellow gender non-conforming pals, welcome back. I'm C28, and I had to use a hairdryer to dry myself from the shower because I didn't put my laundry on. On to the vlog. Today, in sequencing technology, we're going over MIDI. A lot of stuff about the history of MIDI, different sort of connections, different ways MIDI communicates with the instruments. Very interesting names for the types of instruments that MIDI sends and receives from and to. Let's get into it. Of course, these vlogs are absolutely never scripted, so we're just gonna go with it. We're gonna see what happens. Starting from the top, we talked about how there is a MIDI Manufacturers Association in the States and Europe, and they help to define sort of the specifications of MIDI instruments, MIDI stuff in general, understanding how things should be. So they're the reason why essentially any piano you get is going to have MIDI out, and it's going to work for any software. It might have MIDI in, it'll work for any software. You can link any two together and they work because standardized. So there's not some sort of thing where you have to pay someone for licensing, because it used to be that way where, who was it? Was it Korg? Roland. Roland used to have something called the DCB standard, which was the way at the time you had to have machines communicate if they're Roland, and people have to pay for the licensing, and it was not an outstanding system in the 1980s. So fast forward a few, we've got now MIDI, proper MIDI. So how does MIDI work? Well, MIDI doesn't transfer audio, it transfers instead what's known as performance data. It transfers from one place to another. What notes did you press? What things did you do? What should the machine be doing with its sounds? So you've got two types of devices. Bear with me on the names, they're a bit interesting. So the device that gives MIDI information out is called a master device, and the device that receives it is called a slave device. So, interesting naming scheme, I know. I didn't name it, don't blame me. So we were talking about how you can daisy chain together different master and slave components in order to do different things. You also, in addition to in and out ports, you also have a through port, and a through port's very interesting. Through ports in MIDI allow you to daisy chain out the information. So if you have one slave, one master machine that's sending data out to, say, you wanted to send it to 3 different slave machines. You can have slave 1, slave 2, and slave 3 all receive the same input by inputting the out from the master to slave 1, and then through from slave 1 into the in of slave 2, and then through from there to slave 3, and so on and so on. But you run into an issue there. We were talking about how they work. So the reason through exists, and you're not just going in, out, in, out, in, out, is when you have that connected module, you're going to create a giant antenna. And that giant antenna is going to pick up noise, it's going to pick up radio signals, whatever you want. Pretty much actually whatever you don't want. So the way the through port works, it converts the signal into light, and then it has something that picks up that optic signal, and it has a break in there. So there's a break in the connection. But a consequence of that is that your sine wave, which is how it knows the ones and zeros, is it's up, down, not sine wave, square wave, up, down, it slowly becomes a trapezoid, and then a triangle wave, and then a nothing wave over time after so many iterations. So the MMA, the MIDI, what are they called? MIDI Manufacturers Association has pretty much said you can do a max of like 3 slaves to a master before you start getting too much distortion for it to make sense. So that's where you can have, what are they called? See, well, I just had class, I have to look up the names again. Essentially, you can buy a box that's gonna transfer all the data, and it's gonna be the same source data. So while you can use the through on your devices, That's why you might want to use a separate box. If you have like 8 different synths and you got different presets on them and you want to have just one thing controlling them all, well, you might want a MIDI box that can take one in, one out for all of them. And they all receive the same copy of the out. So there's that. Some more interesting things on MIDI are the pins. I didn't know this. Not all the pins are used. Not just that they don't happen to be used. On purpose, there are 2 pins on the MIDI connector that are just straight up not used. So that's TRS. Let's see. I don't think I actually have a MIDI plug. That sucks. I was going to demonstrate. Let's pull up an image actually. Here. I'll pull up an image of a MIDI plug and show you here. Images. Come on. Show me a good one. Please. And thank you. There we go. That's good. Cool. So. Oh. I am all connected. So your standard MIDI plug here is going to have 5 pins. And what's interesting is not all these 5 pins are used. So the 2 on the side here are simply used to differentiate it from this one. Because they're basically the same. And we already have a 3-pin system for something else. But the issue is this is expecting, I think it was a 1.34 volt signal. MIDI sends a 5 volt signal. If you send your 5 volt signal through something that's expecting not 5 volts, it's going to kill your equipment. So this was designed such that you could not plug it in if you wanted to. And because the internet wasn't really a thing in the 80s, you would just know, oh, that doesn't go in there. And that it's just been the same since. So that's not a fun little trivia thing to know. You can ask your friends and seem smart now. Yeah, I think that's about... Oh, we also went into handshake wiring, which is a very fun thing. So we went over how you have slave modules and you have master modules or components, computers, systems, we'll call them that, systems. Well, what if you wanted to have them control different ones? Well, you can use a handshake device, which I have an image here, which is from Full Sail, so I don't think I can show it to you, but I'll describe it to you. So we have essentially a box that receives the in and out data, and you can plug it all into this box as opposed to the machines. And now you can tune into different channels. And when you press a note on one, it triggers all of them. So that way you don't have to worry about all the issues of daisy chaining with the through ports and having that latency, which I forget what that's called. What was the technical term here? It was slewing. So it's when you get your square, become a trapezoid, become a triangle, become a nothing over time. Yeah, I just did a lag. I think that's pretty much it for the lecture. Yeah, that's pretty much it. The only other things that we went over are different types of voicing modes, monophonic versus polyphonic, but they're very common that many people might know it. And for those of you that don't, monophonic essentially means it plays one note. Polyphonic means it doesn't play just one note. It can play multiple notes at the same time. Then you also got paraphonic, which is basically a mixture between the two. It's where you got one envelope that triggers, but you have like different oscillators that can play different times. But the oscillators themselves only play one note. So, stop. Then we got into lab. Lab was fun because lab was just synthesis. That was it. I'm gonna load up lab for you now. I'm gonna plug in my stuff now that I showed you the MIDI cable and disconnected my system. Where are you at? How rude of it to hide from me. Where did you go? Wow, that's so unfortunate that I cannot find the thing I want. Huh. That's you. There we go. Yeah. Cable management. It's something good to have. And if you don't have it, it's something bad to have not having it. Not having it. That doesn't make grammatical sense, but we're going to roll with it. Boom! So lab today, and I can show you all this because it's all my stuff, is we had to make different types of synths. So digital, of course. We're not yet in the wiring section of stuff. So let me turn on my Moog Matriarch, make sure that's on, so you can hear stuff. Is it making sound for me yet? It's not making sound for me. Why is that? Oh, that's why. Cool, but I didn't actually need that. So the very first thing we had to make is a pulse width modulation synth. Now going to the Matriarch, what is pulse width modulation? Essentially it's this. Let me go into PWM, move that there, boom, hello green wire. PWM, pulse width modulation, is when you take the pulse width wave, which sounds like this. Let's give me one oscillator, please. Not that. Which is might sound similar to a square wave, which you might know in like pretty much any bloody retro game has like. If you extend where so the square wave is basically like square, not square, square, not square, or inverse rather. It looks like a square, okay? If you change where these are, and instead of having like your square, pretend there's a line connecting these two. If instead of having them equidistant, you could have one that's shorter, and that is a pulse width wave. And you can change the distance. So, for example, let's see here. Input, output, PWM. I've got an LFO now that's going to move the pulse width wave, and it's going to give us PWM, pulse width modulation. And it's basically squishing that wave and releasing that wave. Try to make that. So let's go into it. So the PWM thing I made was with the ES2. Yeah, essentially just using the matrix on the bottom there, this little section, to tell the LFO, hey, I want you to move the PWM on this thing. And I made a thing that sounds like this. Yeah, and it's polyphonic. So I can make like little fun NES sounds. Oh wow, that's fun. That's the first time we dropped the phone. Yay. Hopefully that doesn't happen again. But yeah, pulse width modulation. Second sound we had to make was a wavetable. Some of you may be familiar with wavetable synths, such as Serum, which is probably just the most popular. I forget, what's the other one called? It's not Sculpture technically is one. Some modeling though. There's a very popular one, I forgot its name. You'll write it in the comment section below, be like, damn it, C28, why do you not know this? The wavetable essentially means you have different waveforms you can switch between. So it's almost as if I were to go on the Matriarch, for example. So I have my pulse width modulation here. And if I'm going to turn that down, that's very loud. There we go. And if I were to be able to have the LFO change the waveform, that would be a wavetable. It's one you can change. But more commonly, wavetable synths will fluidly move between them. And that's what makes them so powerful. You're no longer making a 2D sound that can change. You're making a 3D sound that can change because you have another dimension you can alter with wavetable. And mine sounded like this. Very strange, very alien, and they typically tend to sound quite alien when you do that, especially with two, what are they called? Waves that are not really good with each other. Because the way the wavetable synthesis works on the ES2 is you have preset sounds, and you can move between those preset sounds. In that order, not any other order. So you just have one wavetable basically. You have the one, which is a bunch of waves stacked together, and you can morph between them, but you can't move where they are in order of each other. So you get weird stuff like this. Very dissonant, very alien, weird sounding. So yeah, it's fun. Third sound, we had to make a monophonic sound. You know me. I love acid sawtooths. What amazing sounds. So I made mine an acid sawtooth. I use the retro synth in Logic. Just use the sync mode. So we've got shape 1, shape 2, which are your oscillators, and they are making a sound that sounds like this. Yeah, and it's monophonic because if I hit one note and I hit another note, it doesn't play another one. Technically this is legato because it is playing a note and the envelope's open. If I hit another note, it triggers the envelope, but if I let go, it goes back to that note. It's technically legato, which is not your typical mono style. Typically what happens is if I hit this and I hit another one and I let go, nothing happens. And we're pretending I didn't do that, so like that. Of course, I just let go of the note. And the fourth and final sound we had to make was a polyphonic sound. I went all fancy and used Sculpture. I have never used this before. I saw it. I remember learning something about modeling synthesis in the last class. I was like, yeah, let's try it. Oh my God. If you have Logic and you're not using Sculpture, stop making music. You're done. You are done. Get out, leave. This synth is so bloody powerful. Here's the sound I made, but I'm gonna go through the presets with you. So I made this sound. That's fun. That is very fun. It's got a 6-stage envelope, which typically your envelope is ADSR. Attack, decay, sustain, release. You got 4 stages. This lets things happen after the decay and then again. So you basically got 2 decays and 2 attacks, which gives you this sound. It comes back to you. And it changes when it does that. But let's go through Sculpture now. Sculpture is bloody amazing. I am going to use this in a song. This synth module is amazing. These are presets now. This one's called Ambient Intrigue. And you can change the material too. So you got a little thing in the center. Let's see. This little thing here in the center. Boom. You can change the material type you're working with. So right now it's got something in between steel and nylon, but I can go full nylon here. You can go wood, glass, steel. Pretty strange. And just going through these sounds, they're so beautiful. They're very strange and dynamic, and things are happening that interact with each other, and oh my God. And it's a free thing. It's just in Logic. It's just there. love this thing. But yeah, this is turning into one of the longer vlogs, so I will wrap it up for you. This is not composition time. This is not pure production. This is not synthetic design. This is a vlog. So big on green cable. That's about what I did today. So yeah, that's what I did today. I did class, a little bit of lecture, a little bit of lab, and it's fun. So we're learning about the basics of how these sounds work, because when you know the limitations, when you know what you're working with, you understand how to compose and work with these things better as a sound engineer, which is the basic goal of recording principles, recording arts rather. Recording arts as a degree is designed to, it's not locking you in. There are so many things you can do. Seriously, there are so many things you can do. But generally, it's to make you an audio engineer. So knowing what instruments you're working with is important, knowing their sound quality. But knowing how that's even made, the elements of the sound with synthesis, that is very helpful. I never looked at synthesis from that angle. I always looked at synthesis from the angle of, hey, fun little dial I get to play with and make fun, weird alien sound. That's the angle I still look at it with for the most part. But now understanding, hey, I can remake these sounds that happen in nature, that don't happen in nature per se, but acoustic sounds, and understand what makes them up. So I know better how to use a compressor, how to use a delay, how to use my envelopes, how to use all these things, because I know the quality of this sound. And that's what this part of the class is for. So, yeah. If you've got any questions for me, please leave them in the comment section below. Comments as well. Very much accepting of those. I might get back to them in a future video and post it here in this space. And you'll see your comment. And I'll say, hi, comment, and I'll respond to it. But until then, take care. God bless. And goodbye.